Hey everyone, welcome to my channel. Let me my screen. Yeah, so we have covered so far till joins. I think it's better to review the join once, and once we review that, and we'll go further in the join learning itself, and also apart from join, I think window functions will be learn today, I believe. So let's continue our learning journey. Uh, Let me let's go ahead and read brief information about the joints till now what we have learned. So yeah, yesterday's session I have I have asked GPT that I have answered few questions, and after that I wanna, before go proceed further, I wanna have a brief overview about joins end to end, because joins are the most crucial learning area, and most of the interview questions will have like at least one question from joins will be there in any interview. So that's the reason I was more interested in it. So let's read out this thing. Once this is done, we'll continue further. Okay. So the key points in the join is most common join types are inner join. Of course, that is a default join. I think I have asked the same question to the GPT. GPT. Let's see the answer as well. So left join. So inner join, you already aware, like um, it will just get the matching rows. Left join is all rows from left and the matching from right, and if not, something is not matching from right, the right will have some nulls towards it. And apart from that, right join, all the right table will be there in the end result, and of course whatever the matched from the left will be there in the result. Next, full join is keep all rows from both the sides. So that's what the full join is all about. And left anti join is, so only rows from left that do not match the right. uh, so only rows from left that do not match the right means unmatched record. So that's why it says left anti-join, and left semi-join is only rows from the left that do have a match in the right, but returns only left columns. Um, so So only left. For example, A is a table and B DF1 and DF2. In that, you want to know from the DF1, you want to know what are all the matching records from the DF2. So just you can um, get all the records from the left and only want to have left. There is a slight difference between left semi join and the inner join. Inner join will get matching from the both, but the left semi join will get from the left, but only the matching rows, but only from the left table, not include uh, any regard from the right table. So you can just conclude that, like DF1 has certain number of matching records. Once you the result is from the left semi join. Okay. Next, shortcut versus explicit condition. So shortcut is like if both data frames has the same column name, then you can just mention that column name itself. So it's a shorter version of specifying a key to match the match condition to the join. So it's a short form of specifying the join condition, but you can specify in a long form as well, which is a detailed information. So this is the better way to specify matching key or matching condition, so that the readability will be there. Like, so whenever we are doing coding, right, I mean, obviously we'll do a lot more stuff, and of course we may forget in future. So to avoid that, the readability is the main aspect that that make you remember everything end to end, so that when you debugging or when you're doing any further analysis in future, right, you need to have a readability. So if the readability is there, then you can able to uh, add those points, like connect those dots and easily provide the solution if there is any problem occurs. So, and null behavior also, null equals to null does not match in normal join condition. Unmatched side get nulls in outer joins. So, for example, if you're matching two data frames on a particular key basis, if there is any unmatched um, records are there, then it will concede nulls. It will conceive nulls. So that's what the null behavior specified in the join when you're doing outer joins. Okay. Next example: left join unmatched row, right columns become null. Of course, obviously, right right join unmatched, then you will get right columns all and left columns will have nulls. Okay, next shuffle behavior. Okay, this is a very good important thing to understand is why it will happen shuffle in join cases. When using a join, it will segregate on different key matching basis. So once the key matching is done, it has to collect all the information together, and it needs to provide the result. So that from different partitions, shuffle is like, whenever the control goes through a different partitions to get some values, then it's called shuffle. So the shuffle will happen. So broadcast time, so in that broadcast join, will one table is small. There is a feature of Spark to internally apply a broadcast join, so that if the one of the data set is small that you want to broadcast, like shown in this code, so that will internally broadcast, means it will copy that particular small chunk of a data in each partition, so that join will be done comfortably without any issue, without any delays. It's a faster process. To improve the process, join has sorry Spark has this feature. Next, duplicate column problems. If both tables have some non-join column names, result can become confusing. Okay. Best practice: select needed columns. Okay, yeah. So for example, data frames can be done with one column or maybe more than number of columns. But whenever you're doing a join, or whenever the join is happening, right, obviously will decrease the number of columns, because whatever the necessary columns that are required for the computation, so those things only will be considered for any reason, any business reason maybe. So in those cases, like, try to get a small number of columns, so that to avoid confusion, and use aliases to have a better readability. As I already stated, the better readability is always a good concept to understand. Better readability will always help you to, as a programmer, it will always help you to thrive better in your programming. So one more is find matched rows only. Of course, it is inner. Find unmatched rows only. It is left anti-join. Okay. Without seeing this, we may need to tell. So okay, find matched rows only. What type of join we can use as inner join. So find unmatched rows only is left anti-join. And find rows from left that exist in right. Left semi-join, because it will get all the records that are matched from the left, but it won't show anything from the right. Next, what is it? Keep all left rows and enrich with right. This is left. So easy memory. This is the important thing we can just memorize in an easy way. And yesterday also I have tried to copy this text. Inner is common rows only. Left is keep left safe. Right is keep right safe. Full, keep everything. Left anti, left without match. Left semi, left with match only. Left with match only. Okay, this is the keywords you may need to memorize, I mean, for a better understanding. Next, most important practical rule, before writing a join, ask what rows do you want to preserve. That's what I told in the I stated in earlier is take the necessary columns which are necessary for the computing, then join and use. You see the better results, and it will have a better readability, while you're working on it. And do I need matched or unmatched rows? What I need, what type of join we may need to use, and is one table small enough to broadcast? Yeah, of course we need to look on those aspects internally also. Join will take care of it, but it's always better to keep programming in your control, so the broadcast also you need to do by yourself only. Next, um, okay, ask join keys clean and non-duplicate. Okay, so better our join keys are clean and non-duplicate. That is also one of the better thing to understand. So last, these 7.7 and point 8 is gonna summarize. If you have a better grip on these contexts, then you obviously be a better uh, programmer, you can say, from the when programmer to use join. So it's just for join specific only. Next, mini check. Okay, let's start. Let's check and let's go further. Tell me, when would you use left semi instead of inner join? Okay, let's use this. Whenever I want, yeah, whenever I want only the matched records from left table, then I use the left semi join. So let's see the result. What it says. I think I did a good job in this area, I believe. Let's see. It's taking a bit of a time. I don't know why. I mean, I think I may need to change my system. Yeah, will do. Will do. That's mostly correct. Let's make it sharper. This is refine the answer. Use left join when you want only rows from the left table that have a match in the right table, and you do not need any columns from right table. Yeah, of course. Key difference: inner join returns columns from both the tables. Inner semi-join returns columns from left table only, but the two matching with the right table. Next, filter df1 column on existence in df2. Yeah, it's a business scenario they gave, and when to use a left semi. That's what it is given. Next, quick check. Last one. Okay, means this is the last check for the giant perspective. So, which is more efficient and why? Okay, df1 dot join df2 id, and in join type is inner. Select df1 star all the columns. But I didn't understand the context here. What they wanna? Okay, for example, they took this. Okay, this is the code snippet. For the any earlier scenario, filter df1 based on existence in df2 means semi-join. Of course, we need to do on a based on a key ID, which is better in those. Like Most efficient. Okay, this is a good question actually. Df1 join df2 id inner and select df1 of so and so number of columns. Instead of df1 related column, okay, I think second is better because see, you need not to do. Yeah, it's a burden in the operation, right? I mean, like you in this case, like okay, I have two examples here. One is using inner join and the other one is a left join. Both has to return only the values from the data frame one. Means yeah, left side data frame, that data frame results only needed. So I think okay, see, it needs, if you do the above one, it will create unnecessary burden. Okay, so I'll explain in that way. um, okay. So option 2 is best, as inner and after that selecting is not a good idea. The left semi join will do it automatically internally. So I think 2 is better. So let me see. Yeah, so what happens is, like, minute changes, like small simple conceptual information, you need to have an idea to when an interviewer want to trick you with a small detailing level of question, so there it will create a complication for you. Yeah, so yeah, why? So more efficient because it does not bring columns from df2 and acts like existence check. Less data movement, less shuffle, memory, network, and every aspect. It will be the best thing to do in a simple way. So because see, any inbuilt functions, like for example, if you understand Spark and PySpark, Spark has a native Java and Scala language, and if you do coding in that, you may use some additional features as well. But if you use data frame, you may lose few, like user defined functions and all. Python, if you use PySpark, then you will lose UDF. UDF is also there, but it won't be perform in that way, in an effective way. So that's the reason. So inbuilt things, to use the inbuilt things is the best idea because it will have better resource utilization. So that is the main advantage, I can say. It will have better resource utilization. Okay. So what happens in option one? Yeah, of course, this is explanation of whatever I have said just now. And next, real world mindset. Okay, I just want to filter df1 based on df2 existence. Of course, this is the scenario. This is the same question they have given in the past in the above lines, and yeah. Next step, important jump, window function. So now for the today's topic. Let move window functions. Window functions are very critical to understand. Okay, let's start with the window functions. And okay, before that, a quick check. What is the difference between group by window function? Eh, it's a little tricky question. Before learning it, actually, I have a better idea of. Okay, I don't have much idea about the window function, so that's the reason I'm not sure. I mean, how to answer this question. It's taking too much time. I think it just says I'm not sure. Okay, okay, that's fine. I mean, I think somehow it is getting really slow. I don't know. Like, I mean, okay. Since I said I don't know, so let's build it intuitively. No heavy through. Okay, theory. Okay, core difference. Simple. Collapse rows reduces data. That's group by. Okay. One row per DPT. Original row on window does not collapse rows. Keeps all rows as is. For each employee, show average salary for this DPT. Okay, there is an example they have given, which is for each employee, show average salary for their DPT. Okay, so next think like this: group by summary table, enrich each row. Window is a enrich each row. We need to see further, like I mean, what exactly it is. No, visual data, group by result, of course. So in window function, it kept the data as is, and of course, it is added the average salary at the end. So it is improve the data. It seems it's like enrich the data. That's the correct way of expressing this. So group by collapse, window decorate. So this is a good one. One letter phrases the GPT is giving. That's a very good point to understand this in a better way. So now, yeah, let's go. Let's go ahead. Now your turn. Okay, if you want to collect rank of employees when within each DEPT, group by is enough. I'll say one. Oh, it's really slow. I think there is some setting I have changed. Maybe because of that, it is taking a bit of a time to capture or respond. So let's see. I think I may need to revert it back. I'll do that later. Calculate rank of employees within each department. Okay, window function is the best. Okay, why is not best? Why not group by? Simple. Collapses rows given gives new row per group. Okay, but ranking needs all original rows. Yeah, it has to have all the rows. That's a good. That's a good thing to understand. Okay, yeah, of course. There is a little. That's what interviewer will trick you with small, minute details. So there you'll get confused and provide wrong answers. So that is the reason. Yeah, that's why we are reading. We are learning step by step with GPT. Let's see. But ranking needs the original rows, of course. plus a rank column within each DEPT. So window is the best fit for this particular scenario. Yeah. So when a question occurs, you need to immediately your mind should create a map into end, like how to pursue this particular problem. So if it happened by learning through this, and then, yeah, I think that's very good. That's a very good way of understanding the Spark end to end. So why window works? We keep solvers, of course, lets you calculate row level matrix within a group. Okay. Example problem it gives, and of course you need to import the window library and of course the rank library from the functions. Window is from the SQL.window and ranks is from the dot SQL dot functions. Okay, window dot partition by and order by. So here we don't have a group by, like here partition by and order by. Df with the column rank, comma, rank of rank dot over w. Rank dot over w. Rank function, it's inbuilt function, so rank we can use, and rank dot over w. Over is a keyword. Over is one of the word you need to use exclusively to pursue this. Okay, it's a good. Okay, let's see. Group by, give me summary, give me detailed context. It's window function. Okay, quick check important. Total salary per DEPT, only one row per DEPT. If you want total salary per DEPT, only one row per department, then it is group by. I think I did a typo, but whether it corrected or not, I'm not sure. Let's see. Okay. Yeah, it's a good question and a correct answer. DEPT total salary and row per DEPT. Okay. You are ready for window coding now. Let's do hands on. Okay. Your task: add a column, rank column, add a column. Okay, rank column within each DEPT based on salary. Rank column within each department based on salary. Order by salary and DAC, and of course function is rank. So write the code step by step. Start with these are the two libraries, and the code w equals to window. Let's just blindly write it down without seeing the code. Let's blindly write it. Window. Let's write it window df, comma. On top of df, I need to apply the window and partition by dpt. See, it's taking so much time. Partition by dpt, comma, order by So order by salary. Let's see if it is. I think it will correct a bit. I think I made a mistake, but let's see. Whatever the pattern I understood of the Spark code, I wrote this. So could attempt, but syntax needs to be corrected. Okay. So df comma partition by dpt comma order by correct only no window of. Okay, I wrote this actually. So wait, window dot partition by, the actual syntax is window dot partition by. So it's not window of, it's window dot. Okay, partition by and column operation, of course, column dot description. Okay, column dot DAC, descending order. uh, Here it is order by. Hmm. Order by capital B. Okay. Window dot partition by dpt dot order by, of course, column dot then and operation on top of it. So yeah, now complete the full solution. Okay. With the column rank on top of, we need to apply raw rank dot over we need to. So what, uh, I forgot the code actually. So rank is a new column. We are defining with column. That's a column, and by performing what operation we need to know. That is dot over w is there, of course, because on top of that window only we need to. Uh, so I think rank. Okay, let's write in rank dot over of. It's okay. Let's make a mistake and we'll learn. It's okay. So this is what it needs to put. I specified. Let's see the answer. Yeah, rank dot over w. This is the correct answer. Okay, let's go ahead further. What you just achieved. You now know how to partition data within groups, apply ordering, compute raw level matrix, and it's very important. Okay, so small upgrade. Rank can produce gaps. Dense rank. I think there is one more function called dense rank. Yeah, that is that's calling about dense rank here. So yeah, it will have a better ranking capabilities. So let's see. Mm, Top three employees per. There is a question they have given to answer. Top three employees per DEPT. No gaps in the ranking. That should be dense rank. dense rank. Y is generate ranks without gap. So that is the reason it is. So let's see. Okay, in between, try to subscribe my channel. If any comments you wanna do and give me suggestions, then you're always welcome. And yeah, this is um, I started recently, so I'm not sure, like, I mean, how I'm progressing, but yeah, subject wise, I'm progressing well. But the video qualities, and there are some improvements needed from my end as well, in articulation level. So yeah, I'll improve that as well. So yeah, dense rank is correct. Important ones, okay. What is the top three employees per EPT? Okay, so I could quick recap of ranking functional rank, dense rank, row number, unique sequence. No, okay. Next step would be interview patterns. So yeah, we'll go to the next step later. But as of now, if we go back to the initial window, what are all specified? Spark basics, model, mental model, and data frame basics, and reading data, filter with column operations, casting operations. Casting operations, I think we didn't do it. Let's see why it is given, but why it is not introduced in the chat itself. So yeah, as of now, I'm closing my session. We'll continue the session next time. Thank you so much.